right? I hope you have gone through. So whenever you are searching for some article, right? Whenever you are searching for a particular article related to your keyword or your interest, then you have started your search naturally. So to start a search, what I hope you have some observation on the platform, right? So let me share this Google platform. So if you see, this is the typical the first page of any Google platform links on any browser actually. So this is what it's coming from Google, and they have designed this specific search platform with specific search matrices, right? Because if you compare the search mechanism of Google Scholar, it is slightly different from the Google search engine's performance. There it is having different algorithm because it is integrating all kind of web contents. But in the Google Scholar concern, actually, if you take, it is having a very specific set of web contents, and these sets of contents are basically the different templated research articles, research scholarly articles, right? So Google have created a different index database for maintaining all these scholarly or science research articles. So they have kept all these article and its metadata on a different index database, and they are having this different database or different index database to maintain the database, maintain the index database for remaining kind of data. So at least in the Google search system, you can say, or Google Enterprise, they are having these two index databases. One is for scholarly data documents, scholarly data articles. Second is remaining articles, remaining data items, right? And those all remaining data, contents, data objects are appearing in the Google search system, right? So Google's a search operation in the Google Scholar is having different mechanism of ranking, different mechanism of matching, right? So if you search for anything, so let's say HITS again, I'll get some search for any article in the Google Scholar. So these are the typical views, right? So you can see here is the listed view of articles. It is shown, and actually for this query, this simple user query, you have got various articles, research articles. So if you go to the 10th page, you may be having all possible articles listed for this user query HITS algorithm, right? Your query is this, and for this specific query, you have got some suggestions also. You can select this particular keyword or simple, there's another transform version of HITS. So here we have kept HITS in the capital letters, and in the third suggestion, it is basically lowercase text. Then we can have HITS with some co-citation authority. So there are a lot of suggestions coming, and actually to draw these suggestions, query suggestions, Google Scholar system, Google Scholar basically a query suggestion algorithm has some mechanisms to derive these different keywords or suggested keywords, right? And if you are looking at some page number among the results, naturally there is an algorithm called SERP. There is a concept called SERP, which is search engine result pages. So they are having this mechanism to derive these suggestions also, right? So we will be talking about this phenomena maybe in the upcoming classes. So if you assume that PageRank is used here also, so it is not true. It is not always a correct statement to say that PageRank is working in the Google Scholar also, because PageRank, the first version of PageRank has been proposed in the earliest version of Google Scholar, Google search system, right? But for Google Scholar system, they are having a different variation of PageRank, right? Because if you see in case of Google Scholar, we are having these scholarly research articles as a document, right? And in these kind of documents, we are having some set of metadata, right? So like you can say, if you see a particular article, you have list of authors, year of publications, and actually set of platforms where these articles has been published or submitted. right? And you could have a lot of other meta information also, like references, references which has been used in the particular article, right? So all these kind of meta informations are widely used by Google Scholar system, because they are maintaining all these meta information into their index database, and to provide this basic search which we are right now exploring, this basic search for keyword HITS algorithm. They may be using, maybe Google search system is using these all meta informations to retrieve the data, to arrange the data, right? Retrieve means to match the data for a certain query and to arrange them, right? So naturally they are having this page rank algorithm in the background to rank the data, rank the documents which has been retrieved for this query. So if you can see carefully, and if I raise a simple question for a certain query which is a correct query, I'm not saying this is an incorrect query, we have typed it in its correct form, HITS algorithm. So if I perform this search on this query HITS algorithm, if you can see here, the different research articles have been selected, right? And there are naturally these filters are facets are given for some set of rearrangement of the retrieve results, right? So and there is this filter called you can include patents, you can include citation among the results. If you remove them, naturally results will be lesser. So some articles, some documents have been removed from the matched results, and you have only two things to now operate on the retrieve results. One is you can select a certain timeline, and second, you can have sorting arrangements, sort by relevance, sort by data. So relevance means naturally it is assuming the presence or the availability of these typed query inside a particular result. And if you sort by date, it can use the date value which has been captured in the index database. So we are having very limited set of you can say the features, the facets to operate on the retrieve result, right? But that is not our focus right now. At this point, our focus is to understand on what order basically it has been arranging, right? You can see, because if you have 100 different research articles, if a target is given, if an objective or assignment given to you, can you identify that out of these 100 articles which are matching to your user query, can you identify which one is of the most important, right? So that is coming from the term authority, right? Authority means a particular document or particular web page which is having the highest impact, highest contribution, highest relevancy to a certain user query, right? So out of these 100 research articles, can you identify which article is having highest authority, highest or the maximum or the highest presence in a particular research query, right? So for this research query, can you identify which article is having highest authority, right? So naturally, to estimate that, we will be having, or we will be adapting some metrics, some criteria, right? So in the research or scholarly, actually in the domain, people are having this perception that any research article who is having this citation, like for the first article, you can see it is having cited by 167 different articles, right? 167 people has been used or referenced this research article in their research contribution. Similarly, for second article, it is 75. For this, it is 111. For this, it is 54. This is 157. So if you consider that a research article with highest number of citations can be considered as the authoritative paper. It is having some authority and on that particular domain or that particular research related papers or articles, set of articles. So in the research article or in the researchly domain, this is the one matrix which has been largely used to identify the authority of a certain research article on the domain, right? So if you see mean, this algorithm HITS is proposed by Kleinberg. So you cannot see his article, because we are assuming that any person who is contributing to algorithm. So Kleinberg has proposed this HITS algorithm, but his paper is not appearing. His paper is not having authority, right, among the results which has been searched for HITS algorithm related articles. So you could find that paper on somewhere. I hope it is appearing the very first page. I hope, yeah, this is the article, right? So although it is having 1397, I mean, it is the highest, I think. So highest citation among these search results, but it is appearing in the maybe 6th or 7th position when it is arranged by the relevance, right? So if you change this thing sort by sort, okay, it is throwing up some incorrect ordering. So it is not always necessary that if you run for a particular query and try to identify the most authoritative or most important search result, the Google Scholar system is giving that result or some of the important result in the top 5 or top 10, right? So similarly, there are this term called page authority or document authority. So here in this scenario of Google Scholar, the importance of some research article could be found by utilizing this matrix called references, but it is not necessary. It is not always necessary that if you have a paper or a research article with highest citation index, it could be one of the best paper, right? Because it is always coming from a qualitative or subjective evaluation. But yes, to start the research in a certain area, you could refer these articles which are having the highest number of citations, right? So you can start your search on a certain domain by taking out some of the articles on the highest citation list. That's true, but it is not always necessary that article with highest number of citation is having yes, naturally it is having influences, but it is not always having this authoritative presence, right? So similarly, in the case of social media platforms, social media networks analysis, they are having this presence of following matrices, all those kind of arrangements, and based on these matrices only, these social media platforms are giving you the list of persons, the list of users who are having this blue tick profile, right? So naturally, based on these simple matrices, they are deriving this authoritative or authentic user set, and based on those authoritative or important users, they are establishing that these persons are having highest level of influences, highest number of authority on the particular basically domain or maybe particular set of results, right? So along with these very few matrices, there are various matrices are proposed in the different domains, right? And typically these basic matrices are considered as a part of search engine optimization or any optimization perform a certain platform. Like here we are talking about search engine optimization. You could have your own optimization based matrices for social media platforms. You can have your own optimization based matrices for your own different type of platforms, right? Because if you are working on a recommender based systems, if you are designing a question answer based system, you need to have different type of matrices to define these importance of pages, define the authority of a particular page or a particular document, right? So like we have started the discussion on this link analysis in the last lecture, and we have taken out the basic concept called simplified page ranking algorithm, right? And on that we have taken out few concepts that basically why links are important and how to derive these links, right? So in any kind of link analysis, basically if you want to understand the properties or structure of link or web links or web URLs, you need to take out these link analysis or link graphs, right? So there are various tools available to take out or to draw the link graph for a given a web entity, right? And based on that, you can generate the very first mechanism is eigenvalue, eigenvector, and based on the eigenvector, you can always establish the importance matrices. All these matrices which we have discussed, which we have named, you can derive, right? So basically, we have emphasized on one aspect that this link analysis will give you some kind of importance on the web pages to perform ranking of the or ranking on the retrieved results, right? So naturally, to rank the data, to rank the web pages, we can use page content, right? But along with it, this page content thing, we can use these page rank values, right? Particularly because in the at least in the web content scenario, whenever we are taking out the content from the web, it is widely useful because most of the pages are interlinked. Most of the web pages are having this interconnectivity between themselves. So it is important, and it is useful also to basically have this kind of arrangement where we are ranking different pages based on the interconnectivity, right? Because if you observe in the internet or maybe in the web scenario, web use case, most of the searches, most of the user operations on the web sources on the web or internet are of nature navigational, right? Navigational means you are searching for some research, searching for some articles, and based on the very first set of results, you are navigating from one page to other page, right? So that's the philosophy based on which they have thought about a algorithm which can rank the most relevant or most important or most influential or most authoritative page, right? So this nature of navigation and the placement of URLs and web page, web URLs and links on the each different interconnected pages is the two reasons basically to have these algorithms, right, in the link analysis. So we have taken out the different types of link. So you could have different link analysis arrangements, right? There are 4 types of link analysis algorithm approaches, and based on that, we have observed that this structure-based link analysis is one of the type. There we are utilizing the structure. Structure means the organization of different links on the web pages and how they are placed and how they are contributing to the importance of different pages. Like if 2 pages are placed in the web and page A is having some position or it is placed in the page B, it means page A is considering that page B is important, right? That's why it is basically upvoting. So if you are having your profile page and you are placing some or maybe some other companies placing their URL on your web page or web profile page, it means that organization or company is considering your profile as important. That's why they are placing their business website's URL onto your profile page. So they are basically promoting you, they are kind of voting you. So it is adding value onto your web page. So whenever these 2 pages, your profile page and this organizational web page, will be appearing on some query result, your page, your profile page will be appearing on the first position, and that organizational website will be appearing in the second page, just because of this role of this minor interlinking, just because the placement of anchor text on your web profile page, right? So to take care of all these possible discussion or concept in the structure analysis, link structure analysis, there is this research domain widely called web mining. So this is basically one of the prominent research area nowadays, because there are a lot of issues evolving in the web, right? Naturally, the performance of any search system or any web system, web information system, is widely based on the lot of analytics involved in the web mining, because web mining is contributing to improve the performance of any information system by analyzing, by placing some algorithm for web content analysis or web structure analysis and web usage. So naturally to conduct, so these are the three sub area in the web mining. Sub area means there are the various algorithm has been designed in the past in these three broad areas. There are a lot of algorithms proposed, algorithms and matrices has been proposed in these three broad area, right, to perform naturally mining, and you could have analytics, right? So based on this mining results or analytics results outcomes, you can improve the performance of your web pages or increase the performance of your any system, right? So when we have started discussing this link analysis, it is the subset, it is the thread of web mining, particularly in the web structure analysis, right? Because each and every detail which we have taken in the previous class is coming from this sub part, which is called web structure. So under this web mining, web structure is one area, sub area, and within that we have taken one particular aspect which is called link analysis or link structure analysis, basically, right? And there we have hinted about some of the approaches, right? So you could have these four approaches to perform link analysis, and within that, if you want to adapt one algorithm, like we have adopted link structure analysis to identify the quality of links, to identify the quality of anchor text, we have adapted some matrices, right? So naturally there are various matrices has been proposed, and these matrices are sometimes called SEU matrices, and we have said there are around 21 different matrices which has been currently available for used, and there are various internet sources, various internet web pages where you can have these details about these different matrices, right? So we have taken only a few matrices or few parameters to discuss that how basic basic or simplified PageRank algorithm has been designed, and how this is how we could go for the modified PageRank. This is how we could go for the HITS algorithms, and there are various algorithms available in the worldwide or in the web, which has been adapted by different platforms, right? So along with this PageRank HITS, there are different, like there is Hummingbird algorithm, there is this Clever project which is going on by the IBM, I think it was. So basically there are various algorithms, different algorithms has been designed, though their scope of adaptability is again depends on the matrices which they have considered for their implementation. Like in the case of PageRank, it is the in the simplified PageRank, actually it is the basically number of nodes, and then we have number of links which are placed in the pages, which so these two details are only used to identify or evaluate or estimate the score of a particular PageRank score, right? And based on that score, they have calculated, naturally it is the probability estimation, this PageRank thing. This PageRank estimation is widely used to place a particular page in a search ranking or search ordering, right? So there are different matrices available. You can select one or two or three, maybe based on your estimation, and you can design your own algorithm for link analysis or basically web structure based link analysis. So the objective of naturally is basically is to identify the influential and authoritative pages. This is the broad philosophy, this is the base philosophy of any kind of link analysis. Let me place here link analysis. Under this link structure analysis. So naturally there are two broad matrices which has been initially proposed, that whenever we are planning to perform some analysis, link analysis or analysis of links available in the different pages for their importance, these two aspects are very much important, that you should be identifying the influential and authoritative pages. So influential and authoritative, these two terms could be a little ambiguous or a little confusing, but there are various metrics nowadays available to estimate these two aspects are featured differently, right? So if you go into this SEO matrix list, so there are various terms there is various matrices are given along with their definitions, along with their formulation. So these two terms like keyword density, keyword difficulty, page authority, domain authority. So there are various matrices and the definitions has been widely published, and these definitions are widely adapted by the different search systems, right? Because these definitions are too much generic, so you can adapt the definition, you can adapt the formulation, and if it is required, you can modify the definitions of these matrices also, right? So to understand the broad picture of web structure, the role of web structure mining or role of link analysis, link structure analysis, you can always have these scenarios like citation analysis. Citation analysis is one of the early application of link structure analysis, because like we have discussed in the Google Scholar scenario, because whenever we are dealing with research articles, it is very important to perform some sort of citation analysis, right? Which citation analysis emphasize basically on the most important article, most relevant article, most influential article, and most authoritative article in the particular maybe topic or maybe particular domain, right? So topic and domain are different. Topic means you can search for one particular keyword, like we have done in this Google Scholar today. And domain authority is also one of the important aspects nowadays. So so most of the research article based search platforms like Google Scholar and then semantic web search you can have. So nowadays there are many platforms are available where you can search for the research articles, and they are considering this authority aspect, that what is the position of a research article. So whenever we search for a certain keyword in these platforms, it considers these authority matrices to arrange these research articles which has been retrieved by the platform, right? So citation analysis is one of the earliest you can say earliest application domain of this kind of structure analysis of the links available in these documents. So citation is one of the earliest meta information which has been utilized for performing this link analysis, and nowadays there are various matrices has been used by the different platforms onto these research articles. Similarly, if you look for the general impact factor estimation, so like in the research domain, we used to search for the different important journals in certain area. So we used to go for a factor which is called impact factor of a journal. So it is again an estimation of the authority of a journal in certain domain or maybe in a certain topic, right? So for this impact factor estimation, they are using again the citations, number of contributions, number of utilization of research article coming from journal or going from a journal to calculate this estimation. So you can always search for these things, like what is the citation analysis and what is the citation. So in the Google Scholar itself, if you could see the different matrices are there. So there are matrices like H index, I10 index. So there are various indexes, there are various indicators has been evolved, but the input for these estimation is the citation, is the links. So for estimation of H index, I10 index, and other indexes like impact factor, they are utilizing the different citation networks between the research articles. Similarly, if the most advanced and most latest scenario could be from social networks, because you can see in any kind of social media platform, whether it is Facebook or Twitter or maybe Instagram, any kind of scenario, they are having this followers and following kind of arrangements. Based on that, they are computing the presence of a particular user and its impact, because he's having a lot of followings and he's basically having a lot of follow users, so he could be a potentially important, potentially authoritative person in a particular domain, right? You can always go for this kind of study that, okay, let me explore the Google Scholar platform and try to understand what is the contribution link analysis is having in the performance of Google Scholar. Similarly, you can always perform the comparison between Google search system and MSN and Yahoo, because for the same user query, these different search systems are having different type of results, and it is because they are having because these three different search platforms are always having the similar documents, similar web pages in their index database. But as far as a user query concerned, they are having different arrangements of these results. So whenever a user is submitting a query onto these platforms, you can easily observe, you can always have three windows, one for Google, MSN, Yahoo, and raise the same query onto these platforms, and you can realize that the different arranged list of results has been placed in the onto these different platforms, right? And whenever you are going for a Facebook, you can you can try at least to observe that this is how Facebook is basically having utilized the links. Again, links means the links. So how Facebook is deriving the different links? It could be a list of mutual friends, it could be list of, again, followers and all kind of link, likes and shares, all. So these all meta informations by these platforms are being utilized to perform some sort of basic, additional and advanced link analysis or structure analysis on the pages and on the different documents, right? So with this basic philosophy, we are not taking much details of web mining and of link analysis here, because it will be widely discussed during the this question answering based system discussion and personalized search based systems. So maybe in the later part of this whole course, we will be opening up about the personalized search systems and question answering based systems. So in these lectures, actually, basically, we have planned the detailed discussion on these matrices, right? And we will be taking about these in different matrices on details. So let's go to the again PageRank algorithm, which we have started discussing in the previous lecture. So we have widely discussed these all basic details about the PageRank algorithms, and these are basically the common philosophy for basic, you can say, the simplified PageRank as well as the modified. So modified, when I say modified PageRank, it means, because in the case of simplified PageRank, it has been primarily utilized the number of links naturally, and in this only links which are inbound links, right, to the particular page. So suppose we have given 10 or 20 pages. Among these 10 or 20 pages, naturally, to generate the PageRank score, to generate the PageRank probability for the search, it observes the only inbound links. That is what the simple philosophy of simplified PageRank, which is the first version of PageRank. And if you observe that only considering inbound pages or inbound link are having some biased impact on the PageRank score, and it is widely observed that they are, so now maybe early 90s or maybe mid 90s, they have observed that there are malicious pages has been created to increase the importance of some pages. So if you have adopted simplified PageRank algorithm, and there are various users who has created their these spam websites, spam web pages, just to increase the rank of a particular page. So it is basically creating some kind of biased ranking towards a certain web page. So this has been widely observed by different platforms where PageRank has been observed in mid 90s. So they have come up with this modified PageRank, and they have added this concept called damping factor, as well as the consideration of outbound link also, right? So the modified PageRank algorithm is having only these two additions, right? So simplified algorithm has been extended by the addition of dampening factor as well as the factor of outbound link also. So how many links are going out from a certain page are now also having some role on the role on the generation of the link, generation of the rank of a particular page, right? So you can always search for, you can search in the Google platform itself that can you provide the pseudocode of a modified PageRank algorithm. So you could have some set of idea about that is how a basic PageRank is modified into the advanced or evolved, you can say, PageRank algorithm, right? So there are various platforms which has given this explanation about these two factors. How these two factors means first factor is how dampening factor has been added into the basic algorithm, and how these outbound links from certain page is now contributing to the estimation of rank or score, right? So naturally, along with today's class notes, I will be sharing some of the links of the web pages where a brief explanation about this modified algorithm has been given, right? So that is the basic philosophy which has been modified as far as this new version of PageRank has been proposed. Though there are no specific patents or no specific research article has been coined from coined or maybe published by the Google enterprise, Google company. Like for the simplified PageRank algorithm, there are research articles which has been published by the Larry Page itself. But for modified PageRank has not been published or it has not been patented by the Google Corporation, Google Enterprise. So because that's what we have shared in the previous class, that after this publication of simplified or base version of PageRank, they have stopped. They means Google have stopped sharing the changes on the PageRank by any research article or any patents. So they have kept it in the top secret intellectual property, and they have not published any article or any citation or any patents onto this. So whatever versions of PageRank, whatever modified PageRank algorithms are available, it is widely published or contributed by the different individuals or independent researchers. Like you can also propose your own modified version of the PageRank algorithm. So let's understand the simplified algorithm, then you can adapt. So you need to, so basically the philosophy is that you need to place some code or some section of code, some computing block into the simplified page algorithm to compute the number of outbound links, and second, you can always paste the new approach or now new code to compute the dampening factors, right? So that is the two essential things. But yes, additional, you can always add additional block into any algorithm to extend it, to modify it, right? So whatever articles are available, research articles are available for modified PageRank algorithms. These are coming from the different individual researchers. They are not coming from the this Google organization, right? So this is always an open research problem, open research area where you can also contribute, right, based on your interest. Naturally, one thing is very important here, that this modified PageRank algorithm is nothing to do with user query, right? So whatever score we are generating right now, whatever score we are generating for a certain web page or certain link, it is nothing to do with the user query, because user query will be coming in the future. So because right now we are discussing about the text transformation, right? Text. So within this text transformation block, we are discussing the link analysis. We are trying to rank, we are trying to generate a score for a particular web page, right? We are nothing to do with the user query, right? That is the basic idea of PageRank. So PageRank is the only algorithm which is nothing to do with the user query. It is an independent nature from a user query, right? Other than this PageRank algorithm, there are various algorithms are available which are generating the PageRank score based on or dependent to the user query, right? So it is basically estimating the PageRank based on the page relevance rather than the topical similarity. So when I say topical similarity, it means it is having some relevance, some similarity, some exactness with some given or some available input, right? So it is nothing to do with these kind of situations. It is irrelevant or it is independent from topic or it is independent from the user query. right? So now again it is reiterated that this in and out link estimation and quality of page has been widely done by, or you can always have a code to generate these things, but there are various tools available which are generating which can be plugged with the PageRank to devise the modified or new PageRank algorithm, new version of PageRank algorithm, right? So because it is not having anything addition to the basic or simplified page algorithms, right? So we have properly identified and notified that okay, this outlink thing and dampening factor is something additional into the simplified algorithm to derive a modified page algorithms. So there are this second equivalent available, second type of algorithms available. We have taken this HITS algorithm only because this is one of the second type of page rank algorithm to rank a particular web page, right? But the difference here, it is basically considering the user query, right? Like in the case of PageRank, it is not considering the user query, right? Anything which is appearing in the user query, right? And that's why it is named as a hyperlink induced topic search, right? So when it is said that okay, it is a topic search based algorithm, it means this HITS algorithm is adapted to rank the web page, to arrange the ranked page importance after getting the user's query. That is the difference, right? PageRank algorithm can be adapted before the user query and along with the user query. Both options are available. So because it is not having any direct impact, it is not having any biasedness towards the user query, right? But this HITS is having this dependence with the user query. So that is the main difference between HITS and the basic or modified PageRank algorithms, right? So to perform any kind of link analysis or the estimation of page importance in the case of HITS, you need to have a user query. That is first thing, right? And after getting the user query, you can always identify the relevant page matching pages to a specific user query, right? So the first hand, after getting a user query, naturally your system will be identifying the matching pages. So all these pages where this topic is appearing, this query keyword is appearing, are called authority or authoritative pages or root pages. So wherever, so suppose for a user query 100 pages has been retrieved, and out of these 100, 20 or maybe 30 are having direct presence of these user keyword or topics inside them. So these 20 or 30 web pages will be considered as a root pages, right? Because they are having the presence of this input query. So you can say that these web pages are having some sort of authority, some sort of role, some sort of roots, right? So based on that, if any page who are having their presence into these 20 or 30 pages, right? So for HITS based algorithms, these two levels of pages are also having roles. So these remaining 30 or 80 pages, except these roots and authority pages, are considered as a hubs, basically, because they're also having their presence, they are having their links onto these authority pages. So these hubs and roots both are considered for the estimation of the rank of a certain web page, right? So authoritative pages are the pages where this user query term is placed, and hubs pages are set of hub pages are pages where whose links are available or placed into these root pages, right? So these two set of nodes or set of pages are used to generate the links rank or links position or their importance in the case of HITS, right? So again, we are not going inside the details of these two algorithms. You can always search for the pseudocode of HITS. So again, naturally, so for both PageRank as well as HITS, or for any kind of ranking algorithm, you need to design a link graph. And after designing the link graph to understand the in and out link, naturally you can always map this link graph into matrix, or maybe eigenvalue matrix, something like that. And based on that, always you can define the philosophy of algorithms to compute the rank, right? So you can search for the algorithms and try to get some kind of understanding. But the philosophy of, or the broad steps involved in all kind of structure-based link analysis algorithms are having these three broad steps. First step is to draw the link graph. Second step is to map these link graphs into some sort of matrix arrangement, and based on that you can compute the estimation score, rank, or any probability scores, right? So with this input, I'm closing today's lecture. Right. So whatever question you are having, you can let me know, or you can post in the chat box, or maybe the Google Classroom, right? So there are a few questions which I supposed to share along with these notes also, like as a related questions. So I will try to add those 2 or 3 questions, related question along with it, right? So in the next lecture, we will be taking the last aspect